For number 10, I'm given a quadratic in standard form, and I'm asked to identify the axis of symmetry in the vertex. So in order to identify both, really I just need to use the formula in order to find the vertex, and since the x-coordinate is the axis of symmetry, I really have both answers embedded in just the vertex. So to find the x-coordinate, the formula is opposite of b over 2a, so I do need to identify a and b. A is the number in front of the x squared, which is a -1. There's really a -1 there. And b is the number in front of the x, which is -6. So the formula to get the x-coordinate is opposite of b over 2a. So if b is -6, the opposite is +6. Let me rewrite that. +6. And then the denominator is 2 times a, and I'm plugging in -1 for a. So if I simplify this, I have 6, and 2 times -1 is -2. 6 divided by -2 is -3. So I'm going to record that in that first coordinate for the vertex, which also gives me the answer to axis of symmetry, because it's always the x-coordinate. How do I find the y-coordinate of the vertex? I go to my original quadratic equation, and I plug in what I got for x, which is -3. So f of -3 is saying I'm plugging in -3 wherever there's an x. So -1 times -3 squared minus 6 times -3 plus 5. My first term, I have to square -3 first, so -3 squared is 9, times 1 is -9. The next term, I have double negatives, so when I multiply, that makes a +18, and then plus 5. When I combine these first two, -9 plus 18 is 9, and then 9 plus 5 would be 14. So my answers here at the bottom, the vertex -3, 14, and the axis of symmetry, the x-coordinate, which is -3.